All right, good morning, everybody, and welcome to the first Open Virtual Assistant Workshop. And this is the first event that we are holding as the Open Virtual Assistant Lab. It is a brand new lab, and we just got started. And we're glad that I'm glad to see all of you here. We've been sending messages to each other for the last month or so, and here we are. And thank you for coming. And so this workshop is a little bit rushed in terms of a preparation, and we didn't give a lot of people a lot of notice, but I'm so glad that many of you can make it. There are a lot of people who couldn't make it, and then the workshop is also oversubscribed because we have a relatively small room, and that is why we are now making it available on YouTube. It's like being live streamed and recorded. So please go tell your friends and colleagues. So I'm Monica Lam. I'm a professor in the computer science department. I'm also the faculty director, and I'm organizing this workshop with James Landay. And so we're glad that we pulled it off, and I think we have a really incredible group of people here. We learned a lot in this journey of putting this workshop together. We found that the response has been overwhelming, and we learned that there are a lot of different kinds of companies who are interested in this kind of an initiative. And we kind of rushed this preparation because we felt like the virtual assistant is a space that is moving really fast, and there is really just no time to lose. So we found that there are a lot of absolutely exciting research in this space, and it is going to go on for a while. And this is an exciting time for researchers. We found that there are a lot of companies. There are companies besides the obvious large virtual assistant providers from Apple, Microsoft, Google, Amazon, and so forth. And there are a lot of companies who are interested in also creating virtual assistants. A lot of companies are interested in voice interfaces with their customers. We've also seen a lot of interest from open source organizations. A lot of them are interested in the privacy issues. There are also nonprofit organizations who are very keen to make sure that the technology is available to them. And then we also discovered there are a lot of people from many different from many different countries. They are interested in making sure that virtual assistants technology are available for their languages. So what I think we have gathered together is just it's just a representative of a large group of people who are interested in this space, and we've gathered a lot of exciting, visionary people here, and I hope we can together do something very interesting, and I'm sure that everybody will be learning a lot from this workshop. So we have a very, very crammed schedule, and there are lots of interesting speakers, but unfortunately we can give each person just a small amount of time. So I hope that people can stick around, and we will have time to interact with each other in the reception at the end of the day. So James, would you like to also speak and say hello?
So I'm James Landay. I'm a faculty member also in computer science. I work in the area of human-computer interaction, and I'm one of the co-founders and associate directors of the Stanford Institute for Human-Centered AI, which is helping sponsor this. And some of you have been here at our conference for the last 2 days. I just wanted to thank Monica. She says we co-organize this. She's done all the work here and a lot of it. And I think what's really exciting for both of us is this project that we've started is really kind of in reaction to this realization that the interface of the future is finally starting to come here, and that it's speech and language, and maybe even we'll get to multimodal and other things at some point. And now it's really important for the research community to come back to this area that many of you have been breaking your pickaxe on for the last 30 years, but a lot of people have left because it just never was going to work. And but now really it works. And how are we going to shape it to be useful to people, and our interest in making sure we do this in a way that preserves people's data and it allows innovation to happen in an open way. So I'm pretty excited about what we might accomplish today at pushing this agenda forward. So since the schedule is tight, we should just start, and Monica is our first speaker. So Monica Lamb.
I'm back on the podium. All right. So what I would like to do is to give you an intro to the work we are doing at the Open Virtual Assistant Lab. It's OVAL. If you've been to Stanford, you will not forget the name because that's the oval we have at the front of our campus. We have gathered together a group of faculty from various subdisciplines in computer science. From HCI, we have James Landay, Michael Bernstein. In AI, we have Fei Li, Chris Manning, and Chris Ray. And from the systems group, we have David Mazieres, distributed systems, blockchains, as well as Dan Bonnet, who is an expert in security. We also have Jen King, who is the director of consumer privacy and the law school. And we got together, and very recently, in about half a year ago, we got an NSF grant from to work on this project, and we're very lucky that John Markov wrote us up in the New York Times, and here is a picture of the team. And he calls us the Stanford team that aims at Alexa and Siri with a privacy-minded alternative. It is just to launch the project. We really have a long way to go to make this happen, and I hope that a lot of you can join us in this journey to make it happen. So let's start by talking about the goals of OVAL. This is a really exciting time for computer science research because I think we're seeing three paradigm shifts. The first one is that we have a shift in human-computer interaction, right? I mean, we have been on the graphical user interfaces forever, since the beginning of the PC days. And now we're talking about natural language. We're now talking about the human language, I mean, the preferred mode of communication. And wouldn't it be wonderful if we can just talk to the computer? It'd be so much faster, and it's so much more flexible. And at the same time, we're also seeing a new web. Right? Instead of going to your browser to browse the web, we can now just talk to your virtual assistant. You can get information about the public web. You can get information about your personal accounts, all the different accounts from all the different web services. All the IoTs are out there collecting all kinds of information about ourselves, and now we can also get access to that using a single interface. So the virtual assistant is a very powerful agent, and especially with the access to all our private accounts, it has a lot of private information about us. So that leads to the third issue, which is what is going to happen to privacy? The virtual assistants could be your enemy, but it can be also your best friend, because if we are able to build a virtual assistant that we can trust, then we can use this virtual assistant to help us with a lot of different tasks and different things that we want to do. For example, take sharing. Sharing is fundamental to people. I mean, we are social animals, we need to share. If we have a trusted agent, then we can have the virtual assistant help us share anything digital without having to give up our data to a third party that owns our information. And so what we are seeing here is the beginning of three new shifts in paradigm: HCI, web, as well as sharing. And what we see here is that these are the technologies that have to be done in the open and be made available to all the companies and everybody in the world. And we're not interested in just doing the research. We want to make sure that this technology gets out there. We want to play the role of a neutral party that brings companies together like we have today, to try to really create a new ecosystem based on this open source research. And we want to take it all the way from the collaborative research to industry deployment. And that's that's the mission of the lab. So let's take a look at where we are today. There are a couple of really very, very helpful and powerful assistants today. I would say Alexa and Google being two of the front runners. And if you just take Alexa, today it has 100,000 skills on its platform. And the way it works is that people enter the information about how to interface to their different websites or skills. And all the AI is done in-house, but it is only available to Alexa. So in a sense, what we are saying to all these companies who are putting skills on Alexa is that you get access to all the users that are using the Alexa speaker, but at the same time, you are also sharing your customer relations with Alexa. And to some extent, as Alexa gets access to your passwords and your account information, you can potentially be also sharing your intelligence that is embedded in the data of your customers' accounts. And this is a tricky trade-off for some of these companies that may find this to be threatening maybe to their business. And so there are some pretty worrisome issues there. And what we are really witnessing is the beginning of the emergence of these proprietary linguistic webs. Will there be one web from Alexa, one web from Google, and one from every other company? What does that look like, and what does it mean to the open web as we know it? And the question that comes up is, will there be an oligopoly, a couple of companies, one or two or three, that control this web access and see the billions of users' data? So there is a question of open competition as well as privacy that we are dealing with here. But let's step back for a minute. Does it really make sense to think that all this technology of this linguistic web is going to be built by one or two or three or four companies? Okay, let's take a look at the scale. Today we have 1.7 billion websites out there. All right. And there are all these different websites in all these different languages, and there are representing many, many companies, for-profit and non-profit. How do we scale to take all this information available on the internet and make it available via voice or via language? Okay, that's a lot of work. And then the second question is the cost and privacy. Okay, if you think about the virtual assistants with voice, today we are relying on deep learning. Deep learning relies on getting real user data. And that is very, very expensive if you have to collect a lot. First of all, you have to have access to the users. It is also very expensive because you have to annotate it. And in the meantime, if you're taking real users' data, there is a question of privacy. There are a lot of news stories lately about large companies annotating private conversations, and consumers are feeling, maybe this is not what they want. All right? So that's cost and privacy. Finally, we also have to consider the complexity. Today, a lot of the assistants I keep helping you with with the simpler commands like turning on the TV, turning on the lights, answering simple questions. But if you imagine this virtual assistant has to grow up, it has to be providing more functionality, handling more complex commands, and eventually you're going to be talking about interactive dialogues. There is a lot of work to be done here. If you look at the technology right now, at the language, at the at the AI level, intent classification is one of the most common technologies. It is really not that powerful, but if you look at how we handle dialogues today, you have the dialogue, rewriting dialogue trees and so forth. It is extremely time-consuming, and it's also very, very brittle. So what do we do? So we see that there is a question of scale, cost and privacy, as well as complexity. And our solution here is that we really need to have newer, better technology that helps with the language interfaces. And we want to focus on tools. We want to make a lot of tools, make it available to a lot of people so we can empower the entire industry. And by working together, we can put the entire internet on this linguistic web. Okay, so that's really the vision and the goal of what we are trying to do here. So what I want to do today, in this short talk, is just to give you an overview of the work that we have done, and then there'll be more details that will be provided in the rest of the talks, and some of the talks from our group. And So the key idea that we are pushing for this work is what we call natural language programming. What we imagine is that the user says something in natural language, and then it is directly translated into code. If you look at how assistants are built today, we usually take the natural language and translate it into some intermediate representation that closely matches the natural language in semantics. And that is a lot of work, and you imagine that you have to do that for all the different natural languages potentially, because the languages are different. The way we look at it is that we can approach it in a different way. Okay? After all, this is human-computer interaction. A computer, on the other side, is just a program. Okay? The best a computer can do is to execute a program. Okay? So what we say is that why don't we just go straight end to end from natural language to code. And in between, we put a neural network that will help with the natural language part and have it directly translated into a formal representation. Because after all, that's the only thing the computer can do. And as we increase the power of the virtual assistant, we increase the power of the formal language. So with this translation, you get nothing less and nothing more than exactly what the computer can do. So this is a very different approach than how a lot of virtual assistants are built. So here's just a simple example. If you take a sentence like this, show me the top-rated Spanish restaurants, say, in the area. That sentence itself can be translated into a formal sentence like the one we have shown on the right. And if we map it if we map the problem of virtual assistant into this natural language programming formulation, we are able to do various things that today's assistants cannot do. Here are just some examples of queries that are really pretty natural and things that you may want to find out. So for example, if I want to find a restaurant, it's like, show me restaurants that are rated at least 4 stars. But you know that restaurants that don't have a lot of ratings, the reviews are not trustworthy. So you may want to qualify it by saying that, it's 4 stars, but with at least 100 reviews, okay? So this is a very simple statement. But unfortunately, if you take some simple statement like this, it's already doing multiple joins in the databases, and it actually has to do a little bit of computation. And if you ask this question from the commercial assistants we have today, they can't answer those questions. They can't answer this one, and they can answer 1 or 2 of these examples of queries that we have put up here. Whereas for us, we have a research prototype, and we're able to answer all these different questions because we are using a different technology, which is based on natural language programming. So let me go back to this concept, and I want to break it down a little bit. I want to show you the major tools that we need in order to make this happen. And it is just an overview, and the details will be presented later. So let's take a look at this sentence again. Here is the natural language, and that is the code. And we take this, for this formal language that we're using, we have to invent our new programming language. It is not just Python or JavaScript, because that's unsuitable for the purpose of natural language translation. Our formal language has 2 parts. There is the construct. We called the language itself is called thing talk. How things talk to each other. So the constructs are provided by thing talk. They are domain independent. And then you put, for these construct, put all the different operations together. And these operations correspond to all the things that you can do digitally in the world. Okay, all the information from the web, all the IoTs that you have, these are the operations. So a small, very small number of constructs that connects all the different things together. And that's how we model the formal language. So for example, if you take this particular sentence, primarily this is a sorting of the values of a bunch of fields from a table in a descending order. That's what that sentence actually says. And if you substitute the field with the rating value and table with the restaurant, then you get that particular sentence. Okay, so ThinkTalk, first of all, includes a bunch of operations or constructs that you typically see in query languages. But it can do a lot more. So here's another example. When it comes, so the example I showed earlier is about querying the web. But we also have a lot of IoTs. And there are a lot of tasks that we do that involve putting information from different IoTs together. We would like to be able to have an assistant that helps us connect these devices to solve a problem that we have, instead of just executing simple commands like turn on the light or open the garage door. So here's an example, right? Suppose that people have security cameras now in their homes a lot. And people like me or like you, we do a lot of traveling. And what we would like to be able to say is that if my security detects motion, if I am not home, then take this information and share it with my dad. So my dad can go check up on the house for me, okay? So that's a very useful command, and we would like to be able to just say this in English and have the code be automatically generated using this concept of natural language programming, and have this be run by your virtual assistant that you trust. Okay, so that's the basic idea. And for that, we have created another ThinkTalk construct. Here, these are three lines. When something, get something, do something. We map it into a language on the right-hand side, which says the first line is monitor some event that is generated by the IoT. You get some more information. You compute the result. Take a look at the location. I am not home. Then in that case, go send the message to my dad. Okay. So now here's an example of how we take a sentence, turning it into code. And this is the construct is very, very simple. But the strength comes from the fact that my Thinkpedia, the encyclopedia of all the things I can do digitally, can be very rich. And when you put them together, you can do a lot of interesting things. So here is an example. This is the when, get, do ThinkTalk grammar. When something, get something, do something. And anything that you get in terms of the values, you can do filter on them, and you can personalize it to solve to refer to the actions that you want. Here are just various sentences that you can put together with a very simple grammar, simple construct. And this is the kind of thing we want our assistant to be able to do. And we have a fully working system that is able to do this kind of things. So we said that we have very simple constructs, and by the way, after doing some research in this space, we think that there will probably be less than 100 constructs, okay, that we can put together, and it will be good enough for us to be able to, manage or automate the tasks that we do digitally. So now the next question is, how do we put all the operations that you can do digitally into this encyclopedia so I can refer to them all right? That's the question of scale. So the good news is that there are lots of abstractions out there that we can already take advantage of. So let's start with the web queries. If you look at the web out there, 40% of these websites are using this abstraction called schema.org. Okay, this is a standard that has been created over the years, and it is intended to be used to help the search engine in answering questions. Okay. And so schema.org contains a lot of, these are abstractions. This is restaurants. Restaurants have ratings, locations, and opening hours, and so forth. So it's a standardization that a lot of these websites follow. So what it means is that if we take schema.org and then put a natural language translation to schema.org, now you can access all the websites out there that are using schema.org. And we have created a semi-automatic technique that converts the schemas into natural language ways of invoking these, of getting this information. Not a lot of, it's like not everything on the web is in schema.org at this point, but what we see here is that if we can enable the conversion of information from websites into voice commands or queries with schema.org, we expect a lot more people will be participating and be putting information up. So they don't have to put up their information in any specific skill repositories. They put the information up on the website, and now we can have algorithms that automatically make that information available. And so this is a direction that we can scale a lot of information and bring it online in a linguistic form very easily. So we're very excited about that possibility. So that's the data on the websites. Now there are a lot of APIs that are beyond the websites. And we kind of classify them into 3 different categories. The first one is these unique web services. Facebook is unique, Twitter is unique, and so forth. These are the websites that a lot of people are using today. There are no abstraction for it, and you pretty much have to manually take each one of these and create a natural language interface into these APIs. And we have done about 50 of those, and this is work that we have crowdsourced and performed, and we expect that a lot more people can be doing the same with these public APIs, and we can crowdsource this information. So we expect that to grow. But the good news is that a lot of other services have these standardized protocols. So, for example, newspapers, information, a lot of information that is put on these RSS protocols. Email servers, they use the standard IMAP and SMTP protocols. So by us adding a natural language interface to the primitives that are carried by these protocols, we're able to talk to many different email servers and many different newspaper agencies and so forth. And finally, there's a group of IoTs. And recently we have connected with the Home Assistance community. It's an open source community. And they have like over 1,400 brands of IoTs that have been organized into a very small number of abstract primitives, abstract representation. And now we are in the progress of opening it up and getting the open source community to attach natural language to these abstractions. So we are pretty excited about the possibility that if we work together, we can put a lot of information on this linguistic web. So far, what we have said is that there are constructs, the formal constructs, like when something, get something, do something, or queries, very close to SQL. And then there is the library of primitives. Now we have to put them together. So if we are able to remember exactly the words that we use to put into Thinkpedia, then you can use a simple algorithm that match the sentences into code. Okay? So for example, if I say, when my car is at home, that corresponds to a primitive. And it is not plugged in, another primitive. Send me a reminder email, a third primitive. Okay? If you say the exact words, we can match it, and we are done. But in real life, we're not going to remember those words, and now we have a natural language understanding problem. Okay? So for that same rule that is obviously useful because you don't want to get up in the morning and find your car not plugged in, you can say all these different sentences, and this is where the challenge is. We need to be able to pick up these natural language sentences and say it's the same thing as that simple sentence. And that's where the neural network comes in. So the problem with neural networks is that it takes a lot of data. We talked about the cost and the privacy associated with annotating lots of personal data. So what I'm going to show you is a Toolchain that actually generates a neural network parser that uses no real user data in training. Okay? So the basic idea is that we take, for example, the schema.org abstraction. We take a sample of the data in the web today. We semi-automatically generate all the entries in Thinkpedia. We now know the natural language phrases to refer to all kinds of things on the web. The next thing we do is that we send it to Genie. Genie is a new tool that we have created. It's a semantic parser generator. It takes the Thinkpedia entries, it takes new constructs, such as the program high-level constructs like ThinkTalk, and we also require the programmer to put in templates of how to connect things together. So we are asking the developer to basically program how to generate the training data, okay? And we will explain that in a little bit. So once you program this, we synthesize millions and millions of data. You can keep improving the template, and so we can get better and better sentences. So that helps to teach the system compositionality. And the next thing is that we take 1% of the data and we send it to the paraphrasers in order to learn natural language. And using that, we are able to create a neural network that translates natural language into code. You take the code, and now you can apply it to the web, and it will give you the answer of what's out there on the web. So that's the flow. So it's Thinkpedia, Genie, LuiNet, and ThinkTalk. And these are all the tools that we have created. And they address the issues of complexity through the concept of natural language programming, cost and privacy, because we are really not using real data, and we are talking, and we have a chance of scale because we are using the existing abstractions. So what we are hoping is that by putting the tools out there, we enable a lot of companies to build linguistic interfaces for themselves, put them on their websites, in their apps, in their phone services, and make it available to all the assistants all at once. Okay, the existing ones, the new ones, and more, more assistants that people can build. And as a group, we have been building a virtual assistant, an open source virtual assistant called Almond. Let me tell you about Almond. It's an open source private assistant. It is all open source. That means that you can run it on your own devices. You don't have to share your credentials with any cloud service if you don't want to. So today, your natural language needs to be translated in the cloud. And that is because we need to do the training. But we imagine in the future, we can do the inferencing locally. So you can translate the natural language into code. And I want to point out the difference between this and the existing assistant models. When we translate the language, we are just saying, suppose I say, what is the balance on my checking account? It is translated in the code that accesses a bank for its account balance. But actually, it's not executed. The execution of this code is on your own Almond device. So Almond is the only system that knows the credentials, and it executes the code, and it gets the checking account. So we are separating the translation from the actual private data, and the private data is completely owned by you on your own assistant, on your own Almond assistant. Okay. So it is all open source. We imagine in the future that there will be web service provided, and potentially for a couple of dollars a month, you can have a virtual assistant in the cloud that you pay for, and nobody reads the data. And more importantly, Almond is the first assistant that can communicate with other assistants, okay? And this is very important because we want to enable sharing without a centralized service that sees all the participants, okay? So the idea is that I have my own Almond, you have your own Almond, and we can communicate with this protocol. We have a very rich protocol. It is actually the ThinkTalk protocol itself. And what it means is now that I can communicate using very high-level semantics. I can say it, there is natural language, and then there is code that corresponds to it. And so, for example, now you can combine the concept of natural language programming and communication. Here is a use case. So imagine a doctor wants to monitor the blood pressures of his patients. Different patients requires different kind of monitoring. By using natural language, he can prescribe the program that the patient needs to execute. It's like, and you have to check your blood pressure 3 times a day. And I need to know if it goes above 200 and 120, okay? And he can just say this instruction, make this command, translate it by the natural language on Almond, from natural language into code, and send it to Anne's assistant who can help with the communication. Here is a model where now 2 people can be communicating with the help of their assistants, and the data are shared without having a third party seeing all this information because the protocol is secure. So what I hope I have convinced you here is that we have kind of laid a new foundation for potentially, for all these 3 topics, HCI, web, and survey, and sharing. There's a lot of work to do, but I felt like this is, we have enough of a basis to open it up for more collaboration. And that's why we are launching this lab. And this is the goals that we have for this year. It's pretty, for the coming year, it's pretty very ambitious. So to start, we are launching this OVAL Open Virtual Assistant Lab affiliate program. And we are in the process of identifying the key partners that can help make this happen. Our main goal in the coming year is to put open virtual assistant technology on the map. So far, we have been doing the research and doing the implementation. What we have done is the Thinkpedia, ThinkTalk, LuiNet, and Genie, they're all released. Almond is available as an Android app. It's available on the web. The iPhone version is in progress. We are starting collaborations with companies like Home Assistant and as well as Microsoft on their bot framework. And what we want to do is to create a minimum, is an MVP, a minimum viable product this year. We need to integrate with speech to text. We haven't done it yet. I hope that some people here can help us with this. What we want to do is to put top 10 skills in Thinkpedia. For example, music, news, or restaurants information, and so forth. All right. We want to make it available to every assistant, and we want to make sure that it runs on Alexa, on Almond, our own, of course, Bixby, and Google. And in the meantime, we also want to build up the community. We are organizing workshops, tutorials, hackathons, and we hope to be able to provide tech support so that a lot of people can help build upon our technology and collaborate. And we also want to start working on the next topics. We want to collaborate on research and create new standards. And what we see in the next round is how do you represent dialogues, how do you implement dialogues, multimodal interfaces, standardizing on the communication protocols across the systems, and we also want to get new ideas. So there's a lot of work to do, and we hope that we can get a lot of people here to participate. This is the next year. What we see a couple more years down the road is that we want to be able to start an open industry consortium. And the way we are approaching this is basically the model that was taken by the project software-defined networking. How many people have heard of that term? Okay, then I don't have to explain that much of it. It started as a research project at Stanford about 10 years ago, funded by NSF. It turned into an affiliate program with a lot of major industry, major companies helping to create a standard that is industry strength. And then after that, they have formed an open consortium. And today, there are 150 companies in that consortium, and it was projected to reach about $100 billion industry by 2025. So they have absolutely opened up the space of hardware networking, which was once dominated by just Cisco. And so it's very exciting in the hardware networking space. And we want to see the same here. So we have we've got the NSF research funding. We are starting the affiliate program, and by 2022, hopefully, we can start this consortium. We see the need for a consortium because we have to, for example, do security audits for the Thinkpedia entries. We have to continue to create the new standards, and we want to be able to truly support, provide industry-level support to make sure that everybody can build on top of this open source software. Okay, so it's a lot of things here, and I'm hoping that a lot of people here in this room can help us get there. So that's what we have, what I have. So thank you for listening.